Okay, so now the question is, how do you find the vertical asymptote if you have one? Right, so how do you know if a function f of x has a vertical asymptote? We know you need to check the limit, but this is all sometimes kind of tedious, and what number are you even supposed to test in the first place to know if there's a VA or not? So let's take a look at this example over here. It says determine if the function f of x has a VA or not, and the fx is x times x minus 2, and then x minus 1, and x plus 1. So let me go ahead and write it down real quick. So it says x, and then x minus 2, and then x plus 1, and x minus 1. Okay, the order doesn't matter. I put plus first, so let me go ahead and make it minus again. So here's how you first have to investigate. So first of all, find out what makes the denominator equal to 0. So this first one will become 0 when x itself is equal to 0. Okay, so x itself is 0. The second one will become 0 if x itself is equal to 1. And finally, the third parentheses, x plus 1, will become 0 when x itself is equal to negative 1. So these numbers, 0 and 1 and negative 1, we call these the candidates. So these are the candidates. Okay, so these are places where you may or may not have a VA. So how do you know if the place has a VA or not? Take the number and put it into the numerator and see if the numerator becomes 0. So like for example, the numerator is x minus 2. What number does it take if you plug in 0 in it? If you plug in 0, it becomes 0 times 0 minus 2, which is 0 at the end. So the 0 gave us also a 0 on the numerator, so this is kind of bad. This is not a VA. Now, if you try the same thing with 1, if you put 1 into x minus 2, you would get 1 and then 1 minus 2, which would be at the end negative 1. We did not get 0, so 1 has a VA. So this one is in fact VA because it did not make the numerator 0. It only made the denominator 0. So it's going to be called the VA. And finally, negative 1. If you try the same thing again, if you try the little shortcut, if you do x times x minus 2, you get negative 1 minus 2, which is going to be at the end positive 3. Again, it's not 0, and that would be, a good thing for the negative 1 because now negative 1 has a VA. So 0 is bad because it made the top and bottom 0. Negative 1 and 1 are good because they only made the bottom 0, so they are VAs. Okay, so does that kind of make sense? So if you take a look at the second problem, you've got f of x equal to x minus 3 divided by x plus 1. So what's the candidate? Well, look at the x plus 1 and decide what makes it 0, meaning the root. The root is negative 1. So this is your candidate. This is the number that you're testing to see if it has a VA or not. How do you test? You take x minus 3, the numerator, and you plug in negative 1 in it. So I get negative 1, negative 3, which is negative 4. This is not 0. So we say that x equal to negative 1 has a VA, or itself it is a VA. So this is a place where the function basically, if you look at negative 1, this is a place where the graph cannot cross negative 1. So the function is either blowing up or down, or maybe on the other side blowing up or maybe down. We don't know. We'll have to investigate a little bit more. But that's how you find the VAs. Hopefully that made sense.